Today, we're going to discuss how organizations can achieve FIPS 140-3 compliant cryptography in Node.js applications using SafeLogic's CryptoComply Core. So, whether you're a security leader, compliance stakeholder, architect, or Node developer, this session will show how CryptoComply helps bridge the gap between compliance requirements and modern application development. By the end of this webinar, you'll understand what FIPS 140-3 compliance means, why it matters for regulated environments, how CryptoComply Core integrates with Node, common operational risks to avoid, and how quickly teams can begin adapting compliant cryptography. Many organizations operate in environments where cryptography isn't just a security best practice, but a regulatory requirement. Federal agencies, defense contractors, healthcare providers, financial institutions, and critical infrastructure operators often require cryptographic modules validated under FIPS 140-3. The challenge is that developers want to keep building applications with modern frameworks like Node, while security and compliance teams need assurance that cryptographic operations remain compliant. Historically, this has meant complicated custom builds, platform restrictions, or extensive engineering efforts. So, to reiterate, organizations need strong cryptographic security that maintains regulatory compliance in the ever-shifting landscape of modern development. This surfaces the challenges of complex integration, potential for application redesign, and compliance overhead. Thankfully, CryptoComply Core is here to simplify that process. So, what is CryptoComply Core? CryptoComply Core is SafeLogic's OpenSSL-compatible FIPS 140-3 validated cryptographic module. As such, CryptoComply Core is designed as a drop-in replacement for OpenSSL, becoming the FIPS provider for OpenSSL-based applications. Why does this matter for Node.js? Because Node relies heavily on OpenSSL for cryptographic operations, CryptoComply can serve as the cryptographic foundation underneath Node applications. The result is a familiar developer experience while using a validated cryptographic implementation suitable for regulated environments. What this means is existing applications can continue operating normally, organizations can satisfy FIPS requirements, compliance teams gain confidence in the cryptographic foundation, and development teams avoid large-scale application rewrites. How does Node.js adoption work? Well, the good news is that adoption is straightforward. Node already uses OpenSSL, so instead of changing application code, organizations build Node.js against CryptoComply's OpenSSL-compatible implementation. The integration process consists primarily of installing CryptoComply Core, configuring OpenSSL to operate in FIPS mode, building Node against the CryptoComply libraries, and verifying FIPS mode is active. Once complete, existing Node crypto APIs continue functioning as expected, so developers can continue using these familiar APIs without learning any or entirely new cryptographic framework. Before demonstrating how this works, there is one important operational consideration worth discussing. Even if Node itself is running in FIPS mode, applications may introduce dependencies that bypass OpenSSL entirely. Some third-party cryptographic libraries implement their own cryptography, use native crypto engines, or bundle alternative cryptographic implementations. In those situations, cryptographic operations may occur outside the validated CryptoComply boundary. So the key takeaway here is really just simple. FIPS mode protects cryptography that flows through the validated FIPS provider. When reviewing dependencies, organizations should understand which libraries perform cryptographic operations, whether they rely on Node's native crypto APIs, and whether they introduce independent cryptographic implementations. This in of itself doesn't need to become a major audit effort, but awareness of dependency behavior is an important part of maintaining compliance. All right, on to the demo. Here, I have a simple container that I'll use to build Node against CryptoComply. All right, let's just check, make sure we have everything. I have Node, I have our CryptoComply archive. Perfect. First, let's extract that archive here. All right, now with that done, we're going to run a very simple shortcut script. And what this will do We'll update the OpenSSL config file to enable FIPS. This script is available from SafeLogic with access to our use cases. Perfect. All right, with that done, there is still one minor change that we're going to need to make to that config file to enable FIPS for Node apps. To do so, let's open that file with your preferred text editor. Mine is Personally Nano. All right, and then we'll just add this simple top line comment to the file. All right. Now what this does is basically when Node starts, it is pointing to the OpenSSL init section for initialization. This itself is the bridge between Node's OpenSSL startup and the actual FIPS provider. All right, save that. Perfect. Now, let's go ahead and actually, before we move into the Node file, what we're going to do is set the OpenSSL config environment variable so OpenSSL knows which configuration file to use during runtime. Perfect. And then with that done, we'll run ld config to update the system's shared library cache, thus ensuring that the operating system can locate the newly installed OpenSSL library. Perfect. Now we'll move into the Node directory, which pre-downloaded from GitHub. And this is just Node's source code here, as you'll see, no trickery. And what we'll do here is we'll run the configuration script and explicitly point to the OpenSSL headers and libraries. So script that we found to work, or the variables that we found to work, are here as shown. The -- shared OpenSSL option tells the build flag or the build process to dynamically link against the installed OpenSSL libraries rather than using a bundled version. Perfect. That should be quick. Awesome. And then next, we'll just start running our make command. All right. So following this, the final command you'll run is make install. But as anyone who has built Node from source knows, this process will take a bit of time. So I'm just going to use our favorite baking show trick and hop over to a pre-built instance. So now we're over here on another container with everything pre-built from the previous instructions that I'd shared. Nothing here has changed. This is all built using those same commands previously shown. So as such, let's verify that the build actually worked. All right, first we'll confirm by calling OpenSSL version -a, and this will just let us know, yep, all right, we're still pointing at CryptoComply Core, and you can see that here. This is the 3.6 plus SL module that we were looking at earlier. All right, everything looks good here. So let's confirm which instance of OpenSSL Node is linked against. We'll do that by running this simple command here. All right, looks good. Looks like that is the same version of OpenSSL that we have matched up here. So we're good to go. But finally, we need to check that FIPS is actually, or Node is actually loaded into FIPS mode. So one final check is to load Node's crypto module and check the current FIPS status. Simply do that from the command line interface here with this command. All right, we're looking good. See, a value of 1 indicates that FIPS mode is enabled and Node.js is operating with CryptoComply. So at this point, we've verified 3 things. OpenSSL is installed correctly, Node.js is linked against the expected OpenSSL bid, and FIPS mode is successfully enabled and active within the Node runtime. All of this is to show how the steps we previously shown are simple enough that anyone can get up and running with CryptoComply Core in their Node applications. All right, now that we've shown how CryptoComply Core works with Node, let's recap what we've discussed. We see now CryptoComply Core provides a practical path to achieving FIPS 140-3 compliant cryptography in Node.js by leveraging its OpenSSL-compatible architecture. By building Node.js applications against CryptoComply, organizations can meet regulatory requirements, maintain a familiar development workflow, and reduce compliance complexity, all while ensuring cryptographic operations remain within a validated security boundary. Thank you for joining us today. If you'd like to learn more about CryptoComply Core, access our implementation guides and use cases, or discuss your compliance requirements, please reach out to the SafeLogic team. Thank you.